In Module 2, we'll build up some ideas about atoms, what they're made of, what all of the different pieces mean, and how we're going to use that information going forward. It's probably a good idea to start with some of the really early ideas. So, I'm mostly to give you the sense that we have been talking about this for a really long time, maybe even longer than you thought. So the word atom is from the Greek word atomos, which means indivisible. Now, that word indivisible, maybe not quite the best description, but it we're talking about it in the context where it means the smallest piece that maintains an element's identity. And that, is true for an atom. It is a submicroscopic particle that constitutes the fundamental building block of matter, and it's the smallest identifiable unit of an element. Now, a lot of these ideas came about really early, and two of the very early competing ideas were Democritus versus Aristotle, and maybe only recognize one of these names. Now, what Democritus said was that nothing exists except atoms and empty space. And this is like 5th century BC. And what Aristotle said was that the elements are earth, water, fire, and air, and that everything is one of those elements or a combination of those elements. Now, Democritus was correct. So nothing exists except atoms and empty space. Like this is completely correct. Aristotle, definitely not correct. But I guarantee that you have heard of Aristotle's elements and that teaching and belief. Well, Aristotle was just way more popular than Democritus. So Democritus was correct, but not popular, and he had no way to prove that his description was correct. We only recently got some of the instruments that can perfectly prove what Democritus said. And Aristotle's teachings just persisted for centuries because he was more popular, and there was no way to prove that he was wrong. So, what we can currently see because we have updated instruments is that we can see atoms and we can even manipulate atoms. So, there are some videos posted that are from IBM that show individual atoms and manipulating those atoms to create a really cute stop motion film. The next we went from 5th century BC. The next kind of time point is around the 1800s. So the next piece that we get is atomic theory from a guy named Dalton. And I'm going to give you the mostly correct parts. So, right, Dalton has this atomic theory, and he says elements are composed of tiny indestructible atoms. Now, that's not 100% correct because we now know that subatomic particles exist, and I think physics keeps finding even smaller and smaller components of these particles. It's okay, we don't have to go too small, but we are going to talk about subatomic particles. Another part of Dalton's atomic theory was that atoms combine in simple whole number ratios to form compounds. That's completely true. It will be a whole number ratio, and the word simple is relative, but I don't know. You may have a lot of an atom in a compound, but there will be some ratio between those elements in a compound. And atoms only change the way they are bound to other atoms. They do not change identity. Now, that's true for a significant amount of what we see, but it's not 100% true because nuclear chemistry exists and is an incredibly important component of many of electronic devices we use, cancer treatments, right? Radiochemistry, as in radiation, these things are all very important. So we will not deal with nuclear chemistry, but it exists and is a huge branch of chemistry. Two other things to put with this information. is that Dalton's theory is built on the laws of definite and multiple proportions. So, the law of definite proportions and the law of multiple proportions, the way that they're described in a lot of textbooks can be a little bit confusing. So, I'm going to give you kind of the definition, but then also some examples. So, the law of definite proportions says that every molecule of a compound exists in the same ratio by weight. So, what this means, as an example, is that every molecule of water, which is made up of hydrogen and oxygen, has the same ratio of hydrogen to oxygen. If this means that if the ratio is different, then it's not water. Now, unfortunately, you can't do the reverse corollary of this. So if the ratio is the same, it may not be the same compound, which is fine, right? We get to that more complicated stuff a little bit later, and even some of it won't come up until you take organic chemistry. But you can always use the water has this ratio. So if I have a compound with the same ratio, it can be water. If I have a compound with a different ratio, it is definitely not water. The law of multiple proportions tells us that elements can combine in different ratios. Now, it means that they're different compounds, but it's just a law stating that hydrogen and oxygen do not always have to combine in the same ratio. So a great example here, water will have 2 hydrogens and 1 oxygen, but if you had 2 hydrogens and 2 oxygens, so same elements, different ratio, you have a different compound, and it turns out that that compound is hydrogen peroxide.